Hello everyone, we're going to work on 8.4, which is about matrices. So for the first one, three matrices is given to us and it asks about finding A minus 3B. So first of all, we know that A is of the size 2 by 3 and B is of the size 2 by 3. Since these two matrices are of the same size, we can subtract them, even if we multiply the second one by 3. So the first one is 1, 2, -1, 0, 3, 4. And if you multiply 3 to b, you would get 6, -3, 0. Pay attention that we have negative here. And 3, 9, 6. In order to subtract them, you just subtract them in order or with the corresponding entry. It means 1 minus 6 is -5. 2 minus -3 means 2 plus 3, which is 5. -1 minus 0 is -1. Same idea for the second row. 0 minus 3 is -3. 3 minus 9 is -6. And 4 minus 6 is -2. Part B is about multiplication. First of all, we should check it out if we can multiply them together. So B is 2 by 3 and C is 3 by 3. So C is 3 by 3. Since these two numbers are the same, we are allowed to multiply them together, and the answer would be of the size of these two numbers. It means B times C will be B multiplied by C, and the answer is of the size 3. Okay, this one was 2 by 3. This one is 3 by 3, so 2 by 3 as the answer. So B is 2, -1, 0, 1, 3, 2. And in here, 1, 0, 2, -1, 3, 1, -2, 1, and 0. This is -2. In order to find the answer, we're going to multiply with the help of dot product, first row, first column. That would be 2 times 1, 2, and then let me write it here. So 2, -1, and 0 will be multiplied by 1, -1, -2. And this will be 2 plus 1 plus 0, which is 3. So we put 3 here. Next one is multiplying first row of the first matrix to the second column of the second matrix. So we would have another numbers here. We would have 0, 3, and 1 here. So we would have 0 plus -3 plus 0, which means the answer is -3. Next one, when you multiply the first row of the first matrix to the third row of the second matrix, that would be 2, 1, 0. Okay, 2 times 2 is 4 plus -1 plus 0. That would be okay, 2, -1, 0, correct. 2, 1, 0, correct. 4, -1, and 0. Okay, so this is 3. Now it's time for the second row. So, second row of the first one with the first column here. So it will be It will be 1, 3, 2 times 1, -1, and -2. It will be 1 minus 3 minus 4, which means -2, -4, which is -6. So -6 here. And the next one, which is the second row and the second column. Second column is 0, 3, and 1. So what is the answer? It will be 0 plus 9 plus 2, which is 11. So 11 here. And the last one is second row of the first matrix multiplied by third row of the second matrix, which is 2, 1, 0. So we would have 2 plus 3 plus 0, which is 5. Next part says find the transpose. So let's keep the answer of BC here. So we know that this is BC. But there is a difference between B and C completely, or all to the power T means transpose. So BC, we already have that here. We want to transpose that. So instead of 2 by 3, we would have the size of 3 by 2. And we would switch them over. So 3, -3, and 3, -6, 11, and 5 here. The third part is the multiplication of B and C transpose. First of all, we know what B is, but what is C transpose? It will be of size 3 by 3, and that would be 1, 0, 2, -1, 3, 1, and 2, 1, 0. So we're going to multiply B and C transpose. It means 2, 2, -1, 0, 1, 3, 2, which is of the size 2 by 3, and 1, 0, 2, -1, 3, 1, and 2, 1, 0, which is of the size 3 and by 3. So the answer would be of the size 2 by 3. And we know how to multiply the matrices now. So the answer is, for the first one, 2 times 1 is 2. So the first one is 2. First row, second column, that would be -2, -3, which is -5. First row, third column, that would be 3. Second row, first column is 1 plus 4, which is 5. Second row, second column, -1 plus 6 is 5. And then, -1 plus 9 is 8, plus 2 is 10. And the third one is 2 plus 3, which is 5. Next part is finding 7C plus 2A. First of all, the question is, can we add them together? Let's check the sizes. C here is of the size 3 by 3. If you multiply the scalar 7, that would remain of the size 3 by 3. A is of the size 2 by 3, even when it is multiplied by 2. So in order to add them together, you need to have two matrices that are of the same size, and these are not of the same size, so not possible. Next part is where is that? A multiplied by B multiplied by C. So let's come back here. Okay, so A, B, C. Now, what about the sizes? A is of the size 2 by 3, B is of the size 2 by 3, and C is of the size 3 by 3. We can multiply these together, and the answer will be 2 by 3. But we cannot multiply these two. So altogether, we cannot find the answer for A times B times C. Next question. Show that in general, these are not the same. Okay, so what does the power mean in terms of matrices? This is the same as we do for numbers. So for numbers, when we have 3 squared, it means 3 times 3. In here, when we have this matrix squared, it means you should multiply them together. So A, B, C, D. Since the first one is 2 by 2 and the second one is 2 by 2 as well, the answer would be of the size 2 by 2. And we know how to multiply them together. First row, first column, that would be A squared plus BC. Let me move it somehow. Second one will be first row, second column. That would be AB plus BD. Second row, first column is AC plus CD. And the last one, second row, second column, which will be BC plus D squared. Now, the question is, are they the same? This is the answer for the left side, and this is the answer for the right side. Are they the same? The answer is no. So we know that this inequality is correct. Number 3, for any 2 by 2 matrices A and B, show that A plus B transpose is equal to A transpose plus B transpose. Since it says for any matrix, let's say A is A, B, C, D, and B is E, F, G, H. You can use any letters, but you cannot use numbers because it says for any. You cannot specify the numbers. We should prove it in general. So now, according to the information that we have, we can find A plus B because both of them are of the size 2 by 2. And this will be A plus E, B plus F, G plus C, and D plus H. And from this, we can find A plus B transpose, which will be of the size 2 by 2, but this time it is A plus E, B plus F, G plus C, and D plus H. The right side is A transpose, which will be A, B, C, D, and B transpose, which will be E, F, G, H. What if we add them together? So if you add them together, you would have a matrix of the size 2 by 2, and that would be A plus E, C plus G, B plus F, and D plus H, which is exactly the same. as the left part. So this equation is a correct one.